Welcome back to the 2025 question A4. This is an intersecting planes or intersecting solids question or interpenetration. So the graphic below shows a salt shaker. Okay, so we have a salt shaker here, right? The shaker consists of a pentagonal base pyramid, we can see that on the base, and a square base prism which intersect each other. The drawing on the right shows the plan and incomplete elevation of the shaker. So in part A, they want us to complete the elevation showing all lines of interpenetration. Okay, so let's determine all the points of interpenetration. So we'll go 1, right, where that edge meets that edge, 2, 3, 4, 5 here, 6, 7, and 8. Okay, so we need to locate all those points, those turning points up here in the elevation. Now some will be pretty straightforward. We can just use orthographic projection. So that's the limits method. Okay, and others we're going to have to use reference lines. Okay, so let's start with 1. Okay, so 1 is on an edge of the pyramid. And that's that edge there that we can see. Okay, so here we have 1. 2 is on the back edge, which is that edge there. So 2, project up. I've got 2 there. 3, we don't have as of yet. Okay, I'll leave it for now. 4 is on that edge, yeah. So that's 4. 5 is on that surface. Okay, so this is a surface as well as 2 edges. Okay, we have an edge, edge, and an entire surface, and we know that because we're seeing a point view of that line. We're seeing it there, so that means that entire thing is a plane or is an edge view. So I can bring 5 straight up onto there as well. So that's 5. 6 is actually aligned with 4, so show that it projects up. So 6, that's 6 and 4. So as we're looking to see 6 first, so it's 6, 4. Right, and we've 7. Okay, now 7 and 3 are aligned. Okay, and this thing is symmetrical. So they're actually going to be in line with each other on the front and back. Okay, so they're on this surface. So what we're going to have to do is usually I would do a straight line element from the top or the apex of my pyramid down through 7 and find it as a reference there on the base. Okay, but I've just noticed that that's a straight line there. So when I see it, it's just, I'm not going to be able to determine that. Okay, it's just going to appear as a straight line here also. So we need a reference at a different angle. So what I'll do is I'm going to go parallel to my edge. Get a color here. Sliding set squares, so parallel to this edge. I'll draw a reference line. Okay, or a straight line element. Okay, so that is parallel to this edge here, which is resting on the horizontal plane. So that's a horizontal line. That's a horizontal line. Parallel lines are parallel in all orthographic views. Okay, so let's project that up onto edge 8. Or onto that same edge, sorry. Up to there. Okay, and that's going to be a horizontal line. Okay, so we can now project 7 up onto that reference line or that straight line element. And that will give me 0.7. And then finally, we've edge 8. 0.8 is actually in line with 2 as well. So we're going to go 8, 2. Okay, so we need to go around the house now and draw in what's going to be heavy and what's going to be hidden detail. It's actually all going to be heavy because these edges are all in line with each other, or overlapping each other. Okay, so we're going to go 8 to 2, or 8 to 1, which is overlapping 2 to 8. So even though it's hidden detail, we won't see it. 7 and 2, 7 and 8. We're going 7 to 6. Down to 5. So actually just show that whole edge is heavy. Then it goes back up to 4 and then to 3, which is here actually. So 7, 3, and then back to 2, which is there. Okay. So now I'll just show the edges of my square base prism coming down to intersect. That's 1. That's 2. And that's 3. Okay, and then finally, just to finish off this side of my pyramid. Okay, so that's all the points of interpenetration and lines of interpenetration found. Okay, so a nice one just because everything was in line with each other, the hidden detail. We didn't have to worry about too much because everything overlapped. Okay, now determine the true shape of surface S. So here's surface S. I'll just add a little bit of color to surface S. I'll give it a yellow color. So we can see it clearly. Okay, so surface S is running along there. Okay, so we have an edge view of surface S, okay, which is great. That's one job that we don't have to worry about. Okay, so we have two options now. We can take an auxiliary view looking out directly at that surface, so an X1, Y1 here, and it's an auxiliary plan because we're projecting from elevation. We're creating an auxiliary plan, so we take our heights down to plan. That'll be one option. Or we can robat this surface, so rotate this surface down onto the horizontal plane, project it down, and we'll see it then on the horizontal plane. And that's what I think I'll do. Okay, so we have this line here, okay, it's a horizontal line, so we're looking straight down at it. It's a true shape, true length, so that's a point view of it. So we're going to roll that about that line. So points 4 and 6, rotate or roll back them down. And point 5, let's rotate that down. Moved. Rotate that down also. Okay, so that's then rotated down onto my XY or onto my horizontal plane. Okay, and we'll project them down then. Okay, so if you imagine these points rotating or rotating down, they're going rotating through the line of rotation at 90 degrees. So 0.5 is rotated down to here. So here's 0.5 there. Okay, 0.4 has rotated to there, and 0.6 has rotated to there. So I've got 4, 6, and 5. Okay, and these points have stayed in their original position. They haven't rotated or haven't moved. So let's join 4 to the edge, join 6 to the edge, and join them back to 5, and back to 5. Okay, and that is my true shape. I'll shade that in. Okay, and I'll just label that TS for true shape. Okay, so that was a nice intersecting or interpenetration question there to finish the short section in 2025.